Hi, and welcome to Allen High School's discussion of states of matter and chemical and physical changes. Now, we were talking about intermolecular forces, and remember that a phase change is a physical change. Whoops, I forgot my I there. Physical change. And we are not breaking bonds, so no true bonds are breaking. We're instead breaking or weakening intermolecular forces between molecules. So let's refresh our memory on the names of these phases. If you're going from a liquid to a vapor, it's called vaporization. Now, what I want you to note when we do this, note that energy is a reactant. So energy is a reactant. It's required for the process to occur, and it's entering the system. Now, I'll put these in the blanks later on, but I want to go ahead and label these. This is called endothermic. And what you want to ask yourself is, if you have to put it on the stove, so ask yourself that question, would you put it on the stove to make it happen faster? Then it's likely endothermic, because the stove provides the energy that you need. Now, there is a difference between vaporization and evaporation. Evaporation occurs below the boiling point, below the temperature of boiling. Vaporization occurs at the boiling point. Okay, our next one is vapor returning back to a liquid. And the opposite of that is called condensation. You see it in the picture to the right, condensation. Notice in this case, energy is a product. It's released. It is exiting the system, and we call that exothermic. I can't spell, I guess. Sorry, I'm doing this at home when I'm sick. Apologize for that. Released, it's exiting, it's exothermic. So exiting is exo, entering is endo. Okay. Now, we have another endothermic process. We have solid changing to the liquid. If you took ice and you wanted to melt it faster, you'd put it on the stove. And so this is called melting. You should know this one. And it is an endothermic process. Our next is liquid. Going back to the solid, you notice that energy is a product. It's exiting, so it's exothermic. And that's called freezing. And those temperatures, that's the same temperature for both of them. So if you see freezing point or melting point, that's the same temperature. So sometimes I'll call it TM for T melting, TF for freezing. It's the same thing. These two occur at the boiling point. Okay. Now the next ones may be a little newer to you. Most students know solid plus energy going to vapor. So that's the endothermic. And that's called sublimation. And if we did the opposite, it's called deposition. Do you notice the opposite? One way is exothermic, the other way is endothermic. Energy is a product. It's exiting. It's exothermic. So you're going to have to be able to tell me which ones of these are exothermic and endothermic. So that's an expectation of this page. Okay, what is the difference between, and I've already mentioned this, but let's fill in your blank here. Evaporation is below the boiling point. Surface molecules just can have a little bit higher energy, and they're able to escape a little bit into the atmosphere. Boiling is the change at the boiling point. Okay, so the picture's shifted over. It's from a liquid to a gas below the boiling point. below. So I'm going to cross that off, okay? So I already talked about exothermic and endothermic, and I've already assigned those to the different processes. So this is vaporization. We add heat. We're at the boiling point. This is evaporation. We're below the boiling point. So I've already done these two. You can fill them in here if you would like. I'm going to introduce the phase diagram. The heating cooling curve, we're going to be watching a movie in class on, so I'm not going to make you watch 2 movies on that. But this is critical. Changes in state, you are used to changing the temperature, like I put it on the stove to make it happen. And I think that's commonly known information. What you may not realize or you have forgotten is that pressure changes can change. So when I make dry ice, when I take CO2 gas and I want to make dry ice that you can buy at your grocery store, it's lots of fun. And normally we're going to go right to the solid state. That's the deposition, right? I would typically do this by increasing the pressure on the gas. Okay? So having a high pressure means the molecules are pushed together closer. There's fewer collisions, and they can allow some intermolecular forces to happen. At low pressure, there's not many. High temperatures means more molecules, fewer intermolecular forces. Low temperature means less movement, more IMFs or stronger IMFs. So let's see if I can make this a little clearer via some arrow diagrams here. If I have an increase in pressure or a decrease in temperature, and I'll put that here, okay, there we go. If I have an increase in pressure, a decrease in temperature, I'm going to have more and stronger intermolecular forces. As my pressure decreases or my temperature increases, I will have fewer intermolecular forces. So at low pressures and high temperatures, I have fewer and weaker intermolecular forces. That says kind of with arrow diagrams what was in words here. So hopefully that can help you understand that a little bit better. Okay, I'm going to go over this phase diagram in the next short video. It won't take too long. So until then, this is signing off.